is okay. It's kind of like the one we went over yesterday. I like the ones where it's like 3 plus 3i, or the ones that are just like I or just a number, because to me those are the easiest ones because you can figure out what theta is by just looking at this. Because if I graph 3 on the real axis and 3 on the imaginary axis, I know I'm halfway in quadrant 1, which means I know right away I'm at theta equals pi fourths. And if we find r, that would be the square root of 3 squared plus 3 squared, or the square root of 18, which I'm like you, Colton. I automatically, when I see the square root of 18, I want to break that up as 3 radical 2. And I'm okay with that. And we talked about that when we actually write this out in radical form, you have two options, or in trig form, because you could say 3 radical 2 times cosine of pi fourths plus I sine of pi fourths. And then when you start finding your roots of this, you got to take the fourth root of this, and that looks really ugly, right? So two ways to write this. One way, you could say the fourth root of 3 radical 2, which...
I took it to the fourth power.
Not fourth power, fourth root.
That's what I got.
And the back of the book says 8 because they're leaving it as the square root of 18, and we talked about this, we did talk about this yesterday with the problem, because we're really going to take the fourth root of the square root of 18, and remember the square root, it's like having a little 2 in there. So if you take the fourth root of a square root, you can multiply those together like exponents, and that's where they get the 8th root of 18.
Okay, so the 4 and the square root of 3 and the 2, that's correct.
Yeah, if you wrote this, that's okay.
Which one do you want?
I don't care.
No.
Both are okay. I think 8th root of 18 looks better, but if you wrote this, it's honestly the exact same thing, so it's just which way you want to do it. Okay, so if you wrote that on your paper, that's okay. And you took it to the fourth power. That's de Moivre's theorem. And then for k equals 0, you're going to do pi fourths plus 0 times 2 pi, which is just 0, all divided by 4. So one of those answers would be cosine of pi 16ths plus I sine of pi 16ths. And if you look in the back of the book, they did not write these in standard form, which means you didn't have to write them in standard form. And I promise on the test, the directions will tell you whether you need to put trig and standard form, or just standard form, or just trig form. If you're going to do this in standard form in radian mode, you would just type that in your calculator. And for me, I always just do 2 of these, and then I use the shortcut. So for the next one, I would say cosine of pi fourths plus 2 pi divided by 4. That's going to be 8 pi fourths plus 1 pi fourths would be 9 pi 16ths. And I don't know, Philip was trying to tell me that it's really easy to tell the shortcut because you just add double what the bottom number is every time. I'm sure he's right. I just never thought of it that way. I always just do 2 of them and then I look at the pattern. But he says because there's a 4 on the bottom, he knows you're going to just add 8 to the top number every time, and it worked. But I don't know, Phil's one of those crazy guys that always comes up with the rules, and I never think of it that much. But so I just said, okay, if this is one answer, and then this is the second answer, how did I go from pi to 9 pi? I added 8, so I just do the other 2 without actually doing the work. So then the next one would be 8 pi plus 9 pi is 17 pi 16ths. And then the last one would be 8 plus 17 is 25 pi 16ths plus I sine 25 pi 16ths. 4 roots, 4 answers. And so if you left it, if you did this every time, that's okay too. I am for our prom people that aren't here. Yes. 41, right? Okay, write the complex number in trig form from 0 to pi. And then it says write 3 other possible trig forms for the number. If you look at the back of the book for these, you'll see that they just say you just keep adding 2 pi to the other 3 forms. I don't really care about that other part of that 3 other trig forms. I just care that you can go from complex to trig form. Which one did you say? 39 or 41? 41. Sorry. It's talking too much. I forgot the number. The big thing to realize about this, the same thing with 33 and 34, if we want to go up there and look at that as well, there was some confusion about what that meant, is if it's in our unit circle, I expect that you can give me nice answers. But this, if you try to solve this out, a equals 3, b equals negative 5. So when you solve for r, you get the square root of 9 plus 25, which is the square root of 34. That is not in our unit circle, which means it is not going to be an angle that you just know off the top of your head. No, I just wanted to know what was funny.
No, everybody.
I'm not entirely. I'm not tired. Yeah, never mind. I figured out what I did wrong. I'm not tired.
How do you find theta if it's something like this? You could use sine, cosine, or tangent. You could draw a picture of a triangle, but cosine is going to equal a over r. Sine is going to equal b over r. So on this one, I could say cosine equals 3 over the square root of 34. And then we just use our calculator. So you're just going to do inverse cosine. And I would do it in radian mode. They said, what if they do it in degrees? Am I going to remember? I don't know, but make sure if you're doing it in degree mode that you put a degree symbol in your answer. Because if you don't have a degree symbol, then I assume that it's a radian. Let me check and see.
That's what the back of the book says.
Oh yeah, this is not, your calculator gives you 1.03.
Yeah, that's why.
And then you're like, why do I get 1.03? I look in the back of the book and it's not that. Remember that you have to think about what quadrant you're in. When you graph this point, 3 on the real axis, negative 5 on the imaginary axis, that's in quadrant 4. And remember that your calculator only gives you one of the two answers, which means there is an angle up here in quadrant 1 with a radian measure of 1.03. And that's where you have to think and say, okay, this is 1.03, so how do I get from here to here?
So 6.2 is minus 1.
Yeah. 2 pi minus 1.03 is how you get the answer in the back of the book. That's a little stretch there. So that's how you get 5.25. So you could say, the square root of 34 times cosine of 5.25 plus I sine of 5.25. And then it says write it 3 other ways. That's just silly. But you could just keep adding or subtracting 2 pi, and you would always get the same spot. But I don't really care about that part.
So you have to
You do.
graph.
You don't have to graph it here. We don't. The only complex numbers that we'll be graphing is just the point. Like, if we go up and look at 33 and 34, I just want to talk about the notation of that for a minute. On 33 and 34, they give you the point graph, and I'll tell you that on your test, it's kind of the other way around. Like on 33 and 34, they say, look at this graph, and they make you a little point out there. That's where this is negative 3 and this is 4. And they just want you to realize for part 33, it says, find A, B, and the absolute value of Z sub 1. Well, A is just the real number. B is just the imaginary number. What I'm going to give you on your test is I'm going to say graph this complex number, which means I want you to make the little graph and put the dot out there. But I will also ask you, here they write it as find this. We wrote it in our notes as this. I'm going to say, I don't know why I put a little I there. I'm going to say find the absolute value of A plus BI, and that's called the modulus. That's the distance from the origin to that point, which is just R. It's just a different way of writing it, because if this is B and this is A, then this is R. It's just Pythagorean theorem. So it's just knowing that when I say find the absolute value of that you're just finding the square root of A squared plus B squared, which turns out just to be 5 on this one, because you get 9 plus 16, so you get 5. Same thing for 34 on that one. If you actually try to find the trig form of that, that is not from our unit circle. So on 34, if you try to find, well, we know R is 5 already. If you try to find theta, we could say the cosine of theta is negative 3 over 5. That's not in our unit circle, which means you have to use your calculator. And your calculator does give you the answer over there in quadrant 2. So that's how you get those answers. 2.21. So you can say 5 times the cosine of 2.21 plus I sine of 2.21. Other questions? 63 says convert the polar equation to rectangular form and identify the graph. Remember that when we're converting equations, it's really nice if we have some easy things to plug into. We know that r cosine theta equals x. We know that r sine of theta equals y. We know that x squared plus y squared equals r squared. So sometimes it's set up perfectly that you can just start substituting in. But a lot of times when it's already in polar form and you're going to rectangular form, it's not. And that's where sometimes we would multiply in by sine, or we would multiply by cosine, or we would multiply by r. How do you know what to multiply by? You have to look at what you have and look at what you want. It'd be really nice if I had r in here for both of those, right? So if we just multiply the whole thing by r, it makes it a lot nicer, and it's an equation, so I'm allowed to do that. So I can say this is r squared negative 3r cosine theta minus 2r sine of theta. That works out really nice, because now I can say that r squared equals x squared plus y squared. I can say r cosine theta is x, so that's negative 3x. R sine of theta is y, so that's negative 2y. And it's been a while since we did this, back in like 6-4-ish, I think. But we talked about that when you look in the back of the book at these answers, your answer is not going to match the back of the book unless you do some completing the square. Identify the graph. If you have both x squared and y squared, do you know what kind of graph that's going to be? A circle. Normally, when we write the equation of a circle, you learned this in geometry, and you did some in algebra 2 when you did conic sections, but it's been a while, which is why I don't make you do this for these problems. But this is the standard form of a circle. X minus h squared plus y minus k squared equals r squared, where h and k is the center and r is the radius. So the reason the back of the book looks something like, how in the heck did they get this, is because they, which I'm okay with this, you can leave that as your answer. If this was a test question, I'm okay with that. But just to show you, they're going to add 3x over. They're going to leave a little spot here. And then they're going to add 2y over, and they're going to leave a little spot there. And they're going to complete the square to make these perfect squares. We did this in algebra 2. I know I didn't teach algebra 2, but I used to teach algebra 2. And with conic sections, we do this so that we can put these in standard form and graph them easier, which means you would take half of 3 and square it, which would be half of 3 would be 3 halves, so that would be 9/4. But you have to add it to the other side to keep it balanced. Half of 2 is 1, and 1 squared is 1. So you add that. And that's why the back of the book has this as their answer. 4, 9, 13 over 4. And so if you do it like that, it's easy to be like, oh, that's a circle with the center at negative 3 halves, negative 1. There's enough other stuff I'm making you do in this chapter, which is why I don't make you do that on top of all this. The chapter after this we're supposed to do is conics, which means we review all this, but, you know, we'll see how far we get. I'm not really sure where we're going after this. So. But I'm okay with this as your answer. Yeah. 51 says, find the nth root of the complex number for the specified value of n. Again, when they give you just a number or just I, you should be able to tell me what r and theta are without a whole lot of work. I don't think I'm going to work all this out, but I'll do a couple of it because then you get the pattern. But 1, that's like 1 plus 0i. So if I graph that, that's right there on the real axis, which means I can tell. If I graph it right here, I know that I'm at 0 radians. I know that the length from here to here is just 1. I love when it's on the x or the y axis, or the real or imaginary axis. Because I can say that that's just 1 times cosine of 0 plus I sine of 0. Now you do the 5th root. So now this is what we had to do. K equals 0, k equals 1, k equals 2, k equals 3, k equals 4. Or hopefully you can see the pattern here.
Phillips thing doesn't work.
No, it doesn't. Let's see what. So, if it only works if it's even, I don't know. I didn't really confirm. I just kind of ignore his little theorem because I don't like, I don't know, shortcuts are nice sometimes, but sometimes too many shortcuts just confuse me. The fifth root of 1, the nice thing about this is that's still just going to be 1 every time, so I don't know that there's really a need to write the fifth root of 1. I'll do it one time just so you can see it in the formula. Cosine of 0 plus 0 times 2 pi all over 5 gives you 1. 0 divided by 5 is still just 0. And the cosine of 0 is just 1. The sine of 0 is just 0. So that's just 0. 1 plus 0i is just 1. And that should make sense. The fifth root of 1, if you do that on your calculator, is just 1. The rest of them aren't going to be so pretty, because now you're going to have to do the cosine of 0 plus 2 pi divided by 5. The nice thing is that's just 0 every time, so it's just this number. So that's going to be the cosine of 2 pi fifths plus I sine of 2 pi fifths. It doesn't work because the first one worked out so nice, I bet.
So, n is always the number you divide by?
Yes.
Okay.
N is the number. If you look at our formula, the way we wrote that out is you write the nth root of r times cosine of theta plus 2 pi times k all divided by n.
So that's what messed me up. I always had 2.
Yes, it's not always 2. So then I can just go ahead and tell you the next one, because since this is 0 every time, the next one's going to just be 0 plus 4 pi over 5, or that's just going to be 4 pi fifths. And then it's just going to be 6 pi fifths, right? And 8 pi fifths. How many answers is that? 1, 2, 3. Oh, there you go. So I tried to say the next one gets you back to 2 pi, so that didn't seem right. So 2 pi fifths, 4 pi fifths, 6 pi fifths, 8 pi fifths. It's really just, I feel like doing these problems, 2 big things. Can you go from complex form to trig form? Because if you don't get theta right or you don't get r right, that's going to mess everything up. And then once you get it, you have to know that formula. I'm super mean and I'm not giving you that formula, so you got to know it. Sam, are you sleeping back there? I know Hannah already threw water on you, so I don't know that I would actually be able to go through with my threat, but just want to make sure you weren't sleeping.
How does that work though? It's not a good thing. Waterboarding is serious.
It is very bad. It's torture.
A serious form of torture that like our own government used for like a long time.
They probably still do, I'm guessing. They just don't tell us.
It's like put a cloth in their mouth, then you put a cloth over their head, and then you pour water.
It's really like taking them to the brink of drowning to get them to give you information. Yeah. Yeah, I did. Yeah, waterboarding was just our way of baptizing terrorists. Not really the smartest thing in the world.
She said that waterboarding was like for your baptizing terrorists.
Who said that?
She was live. Are we still recording? Yeah, there we go.
Yay! Let's water.
Do we have other questions?
No, but I'm sure our audience will.
Sure, we didn't say it. We're just quoting what was said.
Yeah, we're just talking about something.
Okay.
Number 2. Yes.
Yes. So, did you have any people when you looked back at the book and didn't match what you had, or you have that you could solve it for?
Right. So I don't know because they keep saying solve for T for the easiest one, but they all are like.
And on 25, it kind of doesn't matter which one, because either way, it's neither one's square. Does that make sense? And so, a lot of people on 25, we were talking about it yesterday in second hour, is because they solved for, I don't know, they had x equals as their final answer, and they looked in the back of the book and it wasn't right. I'm okay with it. As long as you got t out of there, I don't care which one you solve for, even if you don't. Because neither one of them are squared, that should be a line. Anytime you get an equation where neither x or y are squared, that's a linear equation. So the back of the book's going to solve the y, because that's just y equals mx plus b. That's what math people do. But as long as you got rid of t, even if you kept it as a fraction, even if you didn't simplify it, then that would be the right answer. Does worksheets and homework quizzes to pass back to you that I want to get back to you so you have something else to look over.
We haven't,
You do not. You just have to study. Like that's the big thing. I will tell you that because I'm going to break this up into 2 days just because of time issues. It's not necessarily broken up like as all this and all that, but I will tell you that it seems to me like more 6-6 is more the second day. I'm not going to say there's not going to be a little bit of 6-6 on Mondays, but Monday definitely has the parametric equations. It definitely has graphing polar coordinates, converting equations and points. And day 2 has more of De Moivre's theorem and finding the fifth roots and the stuff that takes a lot longer time. Not that it's all broken up just like that, but I'm just letting you know if you're trying to figure out what to study more of, I think all the really hard stuff of 6-6 is more on day 2.
are we gonna have to graph rows?
You might have to make a simple little graph, you know, with 3 or 4 petals. You definitely have I think 1 or 2 graphs, but they're pretty simple if you know the equation. So they make sure you know the equation. There's definitely going to be stuff that just says what graph would this make, and so if you don't know what the equations look like for the Rose curves,
You're
the
giving us.
limacons I'm giving you, right, the cardioid, those I'm giving you those, so you just have to look at it. Yeah, the inner loop one. But there's some that you just have to say it's a circle or it's a rose curve with 4 petals or whatever. But you might have to graph a rose curve. It's not going to be anything like in the book there with 8 petals.
With the,
I think 4 petals will be the most I would make you give.
with the rose curve, does it have to say which axis it's?
No, I think I would say like give the petal length or the, how many petals is what I would choose.
And we need into the symmetry.
I think this is when we talked about this, when we did this, it helps when you're graphing if you know it's symmetric, because if you know it's symmetric, then you don't have to take as many points. But there's not a question on the test that just says, what is this symmetric to? So you don't have to memorize all the R, theta, R negative theta stuff. It's just one of those things that if you think about it while you're doing it, oh, would this be symmetric? Oh, that, you know, it's just one of those things that helps you graph. Other questions overall? I'm going to,
Can you explain like how the petals and like
yeah.
Yeah.
So if we have like R equals, forget what letters we use here, but if we just say A cosine of B theta, A will be your, well maybe we should say the absolute value of A, because I guess it could be negative, would be your petal length. And then B, there's 2 things. If B is odd, then B is your number of petals. And if B is even, then 2B is your number of petals. So like the one that we did on that worksheet, I don't remember if it was sine or cosine, but if it's like 4 cosine of 2 theta, then 4 tells you the length of the petal is 4, and because that's even, that tells me that there's 4 petals.
instead of the same slide.
Yeah, the only difference between sine and cosine is the symmetry. Cosine, it's symmetric along the x-axis. Sine, it's symmetric along the y-axis. But if it's an even number of petals are going to be symmetric over both. Does that make sense? But like if it was an odd one, like let's say I said like 4 cosine of 5 theta, you could figure this out by, if you had to graph it, I wouldn't make you graph one with 5 petals, but you would be like 5 petals, a length of 4, and because it's cosine, when you start at 0, like it's going to have a petal on the x-axis there.
So, at least 2 of the petals will be on the x-axis.
Maybe, yeah. I don't know. But if it was sine, then that means if it was sine of 5 theta, then you know when you plug in pi halves, that's going to get you up to 5 or something, right? Okay. That's really that's the rules about it. So you should know the number in front is petal length, the number with sine cosine is the number of petals. I'm going to pass back your stuff, and then we'll see what questions you have on that, or if you have individual questions. I will tell you that all your homework is due on Monday. My goal is I'm going to get it all graded while you're taking the test on Monday, so I can get it back to you to study. We'll see how that goes. But I think you should have 9 assignments. Let's see if I can find this up here somewhere. Oh yeah, right there. your job. Some people might have 3 days for 6-5 because really did spend 3 days on it, but I called it day 1A and day 1B. And the review counts in that as turning that in on the day of the exam. So if you don't have that together, that would be something that you could do.